is 1.5 times 0.7, 1.05. And now all this here, 3 times the square root of 3 times 1.22 and divide by 2. I got plus 3.17 s squared, and 3.17 minus 1.05, because my brain is tired already, so 2.12 s squared. Good. Other questions? Anything else you would like to continue? Let's go back to the list. So I would like to choose another optimization. Are we okay with Newton's, L'Hopital, graphing, or any of this before we choose another optimization? Is there anything else you would like to look at right away before another optimization?
I'd like to do another L'Hopital's, but we can do another optimization first since we're already here.
Okay. 8, page 9. Okay, I like to look at a problem with a poster. Something like this. The top and bottom margins, let's say 41. Unless you have any other optimization from WebAssign, I'll be more than happy to work on those. So the top and bottom margins of a poster are each 6 centimeters. So top and bottom. Okay, so here's the poster, and here's the printed area, and we have 6 and 6 here, and we're talking about centimeters. And the side margins are 4. Okay, 4 and 4. If the area of the printed material on the poster is fixed at 384, so 384, of course, centimeters squared, find the dimensions of the poster with the smallest area. So they want us to determine the width or the base and the height, the width and the length, if you want, for the smallest area. Smallest area. Okay. So we are given the printed area. This has to be fixed. So the printed area inside is 384 centimeters squared. But we want to determine these sides, I mean the base and height or width and length of the poster. That will give it the smallest overall area. If I denote this piece by X, and if I denote this piece by Y, then I know that X times Y has to be 384. This is fixed. Okay, but now can anyone give us this measure based on what you see here? And can anyone give us this measure based on what you see here? Can anyone give us this length?
X.
Yes.
X plus 8.
Yes, X plus 8. Very good. 12. Yes, and 6 plus 6. Yes. Y plus 12. Awesome. Everyone sees that? So this is X, but there are 4 and 4. So this must be X plus 8, 4 and 4. And the same thing here. This is Y, and we're adding 12 centimeters. Awesome. So the area that we are interested in, I'm going to denote it by A, uppercase A, is X plus 8 times Y plus 12. This should be, so find minimum. This is what we want to find the minimum for. Okay, perfect. Good, so I have a function, but the problem is I have two variables. So it was not difficult to come up with an area that we are asked to minimize. But the problem I'm having now is that I have two variables in it. This is the function and the two variables. I'm going to distribute. So it's xy plus 8y plus 12x plus 96. And at this point, I have to get rid of y. Get rid of y somehow. Yeah, that's why they're giving us this. So we can get rid of y. How do I get rid of y?
Our first, yeah.
So what do I do?
Y equals 384 over x.
That's,
just take that and plug it in.
Exactly. Not here, because there is no point. This is already 384. But definitely in here, because this will become 384 over x. And now I have a function that I can confidently say it's a function of one variable, function of x. So this is 384. This is plus 8 times 384 over x plus 12x plus 96. I will simplify further because I have 384 plus 96. What is that? 0 and 1, 8 and 1, 480. I'm assuming. Let me know if it's correct. And then plus 12x, and then this one, what do I have? 32, 64, 67. Correct my numbers, please. Make sure that I have the correct numbers. 8 times 384. Yeah, I got that right. And it's 384 plus 96. Okay, yeah. Better check then, sorry. Okay, so now we know from this moment on everything is easy. I have a prime. This is 0. This is 12. This is minus. Be careful. Please remember, when we differentiate 1 over x, we get negative 1 over x squared. Very important property here. Very important. Okay? So minus 3072 over x squared. I have to find the least common denominator, which is x squared, and I have to multiply this by x squared. 12x squared minus 372. I'm going to write the function again here. And that's my page 10. So a prime of x equals 12x squared minus 3072 over x squared. And yes, we have to set this equal to 0. And yes, when we set it with, or try to see if it's undefined when x is 0, but the function is undefined at x is 0 as well. So when it's 0, when a fraction is 0, only the top we know it's 0. So 12x squared minus 3072 has to equal 0, or x squared. Let's see if 3072 divided by 12, 256. Very nice. And the square root should be 16. Yeah, look at that. Nice. Yes, I should write equals plus or minus 16, but of course it makes no sense. So x is 16 centimeters. If x is 16, yes?
Why would be multiply 12 by x squared? I may decide to write it as a single term.
I will not be able to set it equal to 0 if I don't do that. I mean, you could, in this case, yeah, I guess you could move it to the other side, but you still have to cross multiply, so it's the same thing. Yeah, because you have two fractions, I understand. Normally we need to do that for sure if we have 3 fractions or more, but since we have only 2, you can just set it equal to 0 from here, but you will still end up cross multiplying anyway.
Right.
It's a very good point. Let me show what I'm saying, because you're correct. It's fine. So 12 minus 3072 over x squared equals 0. This will be still the same thing. And you will still get 12x squared equals 3072. And you will still have to divide both sides by 12, and you will still get this. But you're correct because you have two fractions. But if you have this, let's say, I'm going to erase it, plus 1 over x minus 3 over x squared, you cannot do that. You cannot separate three terms. But with two terms,
Okay.
yes, you're correct. One or the other. I guess it's a matter of habit. I prefer fractions from the beginning and 0 on one side instead of separating them. It's a matter of habit. But you're right. Yes, you can do that because you have two terms. Absolutely. Agreed. Okay, so we got 16. So if x equals 16 centimeters, y will be 384 over 16. And lazy people use the calculator. 24. So then y equals 24 centimeters. Okay. What? No clue. I don't know if this gives a max or a min. No, have no clue. I will in a minute, but right now I don't. And whatever, I don't know. I have to look at the function. Okay, so I know that this is 0. Another reason why I need it like this, because for studying the sign, it will be always easier. You cannot study the sign of this, but you can study the sign of that. So the denominator is not a worry. So let's see the numerator. With 0 is definitely negative. With 20, 400, 12 times 400. Yes, it's over that. Positive. So now I know. This is definitely the minimum. What is the minimum? I don't know. I will. In the function, I will plug in x being 16. So that will be a of 16, which is 480 plus 12 times 16 plus 3072 divided by 16. I don't know if they asked for the minimum, but I don't care. I'm going to determine it. 480 plus 12 times 16 and plus 3072 divided by 16. Okay, 864. And it has to be centimeters squared. And this is in centimeters. Any questions? Any questions on this problem? Okay, so you said we wanted to go back and look at L'Hopital's rule.
Yes, please.
Perfect. We had one problem today. I'm on page 11. 11. Okay. So I'm going to share my screen. And L'Hopital's rule is in 4.4.
Can we do
Yes.
44? That was from the homework.
Yes. I don't remember what it is. I did not write the solutions yet. Can you give me? Oh, you don't have to give me. It's right here. Oh. This one?
Yes, please.
Perfect. So limit as x approaches infinity from the square root of x times e to negative x over 2. Perfect. Okay. So let's stop sharing. Yes. Like always, we have to plug it in so we see what it is. And of course, this approaches infinity. This approaches negative infinity, and as we know, e to negative infinity, I shouldn't write this, but I have to, e to infinity, so this approaches 0. So this whole thing approaches 0. So what does this mean? It means that we have a situation that we really like, and that situation is 0 times infinity. This is not bad. We prefer this, of course, but this is not as bad as 1 to infinity, 0 to 0, infinity to 0. No, these are the ugliest ones. These are the best, and this is okay. It just needs algebraic change, manipulation, I like to say, or just rearranging, algebraic rearranging. Okay, perfect. So, and then I have limit. I'm going to copy it again here. And because this has a negative power, maybe I did write solutions for this. Well, now I remember writing solutions for this. Because it has a negative power, it can go to the denominator, e to x over 2. And I hope that this did the trick, and it did. The numerator is infinity, and the denominator is infinity now. So all I have to do is just a simple change, a simple manipulation, change the function into what I really needed. So I can apply L'Hopital's rule. So then limit as x approaches infinity, 1 over 2 the square root of x over e to x over 2 times the inner function prime. So at this point, the numerator, let me write it one more time. Do not drop the limit operator. We have not applied it yet. X approaches infinity. So this is 1 over 2 the square root of x. This flips to the numerator over e to x over 2. Now you can simplify because you're simplifying factors, but this approaches infinity, this approaches infinity, and 1 over infinity is what? And now I'm applying the limit operator, and I can write the final answer.
Zero?
Yes, indeed. You can also say, because it's a limit at infinity, and because I got a number, it means y equals 0 is a horizontal asymptote at infinity.